Welcome everyone to SpaceGeekSpeak. It's fantastic to see all of you today. We are in for a real treat as we gather to learn from one of the brightest stars in astronaut training. This is a person whose work has shaped the way we get our astronauts ready for the incredible adventures for space exploration. Allow me to introduce one and only Frank Hughes, a true pioneer in astronaut training with decades of experience at NASA. Frank has been the mastermind behind the training program that prepared our astronauts for their missions. His dedication and expertise have been a key part of our journey to stars, and he's got some great stories to tell along the way. Frank, it's yours now.
Okay, thanks, Svetlana. It was great to see you and to everybody. It was my good luck, I guess it is, that I joined NASA at the right time. Forgive me. I have a toad or frog or something in my mouth there. Anyway, it's gone along. I joined NASA in 1966, and at that time it was interesting. Apollo was just starting up. The first mission that I worked on was Gemini 9. And it's interesting, 8 is the one where the spacecraft went out of control and they had to do they only got to stay in orbit a little more than 24 hours. And that was a big deal. In fact, it was still being debriefed there. Everybody was still on the after morning quarterback, about what the crew should have done and so on. So it was an interesting thing to see that kind of behavior. Influenced me a lot to see that there's more than one way to do things, and then there be really more than one. Should we focus on one way to do things like that? Anyway, as Svetlana mentioned, I've written a book, published it this year, and it kind of takes a look at that training over the years. So from Mercury, basically when it started until the middle to late shuttle and into the space station, how we prepare training and what's going on, what should be going on. But mostly, I took advantage of a lot of things that I happened to see, and so the way I did that is to tell a lot of funny stories, and that's what's going on right now. I will. Let's see, Svetlana, give me the thing if we would.
You can share if you have slides or if you have any visuals.
Okay, let me go back to it here. Okay. See, there it is. Also do something else. I've been playing around with things and that screen. I want this picture. Okay. What I'm going to do, just going to get up here. I was trying something a little different. The book is called The Great Apollo Trainwreck. Okay. And that came from a real special deal. Well, if you think about it, the Mercury spacecraft looked like the Mercury simulator, okay? And the Gemini simulator looked like the Gemini spacecraft. When you saw the Apollo train wreck, let me get rid of this thing. I got it up, now I can't get it down, hang on. I'm always trying something new with Svetlana.
Always something new and always something learning, right?
Yeah, it's something learned. It's
You probably opened the window in your other screen if you have a double screen.
yeah.
So right
Now
now
what are you
seeing
seeing? Are you seeing just me, or are you seeing?
we're seeing your computer screen with all the small
Okay.
pictures,
Okay.
tiles.
Go back here. I'm share screen.
So you're sharing your screen right now, but it's your.
Is it a Mercury?
Yes.
Are you seeing a Mercury?
Now it's Mercury. Yes. Mhm.
There you go. Okay. Anyway, like I said, the simulator, this is the Mercury spacecraft, and this is the Mercury simulator. And they were talking about that back in 1960, 61. And you could see the shape is kind of similar. This is the Gemini spacecraft, okay? 2 people in it and everything. And this is the Gemini simulator. It's up in McDonnell Douglas where it was being put together. You see this is John Young, Gus Grissom, because they were going to fly the very first Gemini spacecraft flight. That's my old boss, Ryder McCaffrey. Well, the thing is, Gus, after he finished that flight, he was assigned to fly the first Apollo spacecraft. And the day that I got to Kennedy Space Center, by the way, the training was mostly done in Florida, not yet in Houston. And when Gus walked in the room, because they said, here, we're going to get to show you the new Apollo simulator, and he was excited to get there. And then he walked into a room and he looked at it basically, and it's quote, because I was standing next to him, he said, that looks like a goddamn train wreck. This is the Mercury thing. I wanted to say that. That's a picture of the spacecraft. And so he thought it looked something like that, but this is what it looked like. Buried, it's actually this simulator cockpit is inside underneath that. For the first time, unbeknownst to Gus, but we had visual systems. That is, we were able to see the stars, the Earth below, the moon below, and all kinds of other things like that. And of course, because it was a dual spacecraft, we had the ability to show the opposite vehicle. Whichever one you're in, you could see the other one. And that was a big thing for rendezvous and docking and so on. To get into this thing, you had to go around the back. There was a big stairs going up, and this is the module is up in here. And this is a good double exposure that was presented back in Apollo. So in the crew, inside the crew cockpit, you had the 3 seats right here, and the cushioned seats that you'd use it hit the water. These are shock absorbers. It's hanging from. Okay. But anyway, that was the whole idea. This is the command module simulator. We go on to that. Morning, Dave. How are you?
Morning.
I want to get a bigger picture here. Sorry. Okay. I'm going to get you over here somewhere else. Inside that simulator, you had this kind of space. It's enough room side by side for the 3. So it just took from the 1 to the Gemini 2 to the Mercury, the Apollo 3, and you can see these shock absorber things hanging down. They're also big time. You had fluorescent lights in here. It was like big time days. Enough aside, the guys for launch were laying side by side, as you know, with hand controllers on both sides of, so people could take over and continue the mission. The instructors down here, this fellow, a good friend of mine, still Dan Bland, you got the idea that inside the cockpit, you had all the switches and controls. Down on the console, you had replications of it. Like up in here, this is caution or warning panels and everything. So this is what it looked like. The Mercury simulator, the Mercury vehicle itself, had no computer on board. And of course, it also didn't do anything. That is, it had rotational control, but it had no translational control at all, except 3 solid motors to be used for deorbiting. When you got to Gemini, it was a lot better. You still had those 3 big motors to deorbit, but then you had translation capability, which is, of course, what we needed. It had what we would consider reaction control jets now, and they worked a whole lot of good. We could do the vehicle things, but I'm talking just training right now. It's interesting. When we got to Apollo, this simulator also had about 500 malfunctions built into it, and that 500 was more than enough. In fact, back here behind Dan's hand is where you could put in as many as 10 malfunctions simultaneously. We never did that. It didn't make sense pedagogically, but it was a really good deal. Close vision of the thing. This is the command module simulator. You knew it. There were 2 8 balls, or attitude direction indicators, we call them. Fuel things over here, environmental controls over here, and every one there was a switch position, illuminated light, or sprill, they called it in those days. But you get the idea. And then here is the MIT computer, digital computer replicated here, so you could see when somebody was keying anything in and what the displays would show. Okay. So that was kind of what we got going. Now the simulator, everybody talks about simulator. We had a lot of people got into the simulator all the time. In fact, it was a big draw for Hollywood people, politicians, all kinds of people like that. One of the best things is in the simulator, you had a model house. So you would put in this vehicle, in the command module simulator, you put a model of the LEM, and vice versa. You have a nice model of the command module. It was a television system. You moved back and forth and so on, and give you a good view of what the target vehicle looks like in a background of stars too. This is the lunar module simulator. This has happened to be the one that was in Houston. Same kind of thing. The cockpit of the shuttle, of the LEM is right here. And then there's 2 windows in the front of it that give you the outdoor in front of you when you land, so you can see where you're going when you're coming down landing. And then there's a telescope up on top, because I would use that for aligning your platform and navigation while you're around the surface of the moon. Those landing displays took most of their information from this. This is called the LNA, landing and ascent thing. So what it was is a big XY plotter here, big. I mean, we're talking about tons, and then 2 cameras looking up into this thing. The lunar landing surface was hung upside down because the magnification on the cameras, if there was any dust or anything on it, you'd get a problem. And in fact, this is the cockpit, get into the lunar module. You didn't go through that in the real vehicle. You went from the command module, and there's the hatch up above, which is for realistic purposes, but we never used it because it weighed way too much to like get into it. But there's that hatch up on the ceiling, but you can see what the vehicle looked like inside. And you're looking through that door in the hatch. That's actually where the flight computers were and things like that. Here's down below. If you've been into the vehicle, you get to where you open the door and go outside. And here it's kind of interesting. This is when you get ready to deorbit, after you landed successfully, this is where you let pressure go. And then over in here, there's a latch that you open, swung the door in and started getting out. I want to stop there. I want to say that I just got through working, in 2022 for a thing that was called 11. Now it's out on the street called Fly Me to the Moon. And I want you guys, after we're talking about this and looking at this, I want you to go to the movie. It's a rom-com. It's not for, it's all for fun. That it takes place before Apollo 11 launched down in Florida. So the hero is a launch director, and the sweetheart person is Scarlett Johansson, and she is a marketing person who's hired by NASA to try to people with more interest, continue to be interested in space. Anyway, as this goes through this thing, I was down there just to train the three astronauts playing Neil, Buzz, and Mike. It was not to help Johansson go through the romantic comedies. I think she handled that pretty much by herself. But it is a good show. A couple things, because when I took the contract, it was I looked at the script and I said, well, this will give the people that never thought we went on the moon just a really good thing about it. But it also, by the end of the movie, I think you could see that it was easier to go to the moon than it was to fake it. Okay. So I trained, when you look at the movie, I trained the three astronauts, and I like to say I trained the cat. You just have to go to the movie and figure that out. Astronauts training that was going on. I've had a lot of people through my career, they said, well, do you ever meet any astronauts? And I always say, yes, sometimes, you know. It's like, because they're just working with you. It's like the same organization, the same everything. We played softball together. We went drinking together. And one day somebody asked me if you ever knew any astronauts. And I was thinking about a guy that's still sleeping on my couch at home after I left work for work. Yes, I see them once in a while. Anyway, there's Neil and Buzz in the short sleeves going through. In fact, just to give you an idea of that same picture, here's Neil walking in from the parking lot into their flight crew training building in Florida. Buzz was the only one on this mission that drew a Corvette. That's a whole lot of stories about Corvettes in the book. And then here's Mike coming in with his cup of coffee. Neil was going to eat. So he's coming in, but he has just finished all the books. There's a story. During the night, he was studying that at home. He wasn't out drinking. Separate things to talk about this a lot. I'm going to talk to a few things today, just for a minute, about things that you knew about but didn't know about. For example, who in here can speak up? Yeah, just speak up. And what vehicle is this?
Saturn 1.
Saturn 1B, actually. Okay. Saturn 1 was an interesting thing. We were going to go to the moon, and we were doing it in spades. There were 10 Saturn 1 vehicles they bought, and we used them all. And there's 10 Saturn 1B rockets that we bought and used up. A lot of things. 1B with the crews flew for ISTP. They flew the 3 flights, the manned flights, to go to Skylab. And this vehicle set up, this is for Apollo 7, okay? The vehicle that we had used for Apollo 1 was used for something else. It was a test. But what other vehicle did you ever think about that had this kind of thing? And I'm going to just show you. There's a couple things in here. Up at the top, up here, something that on these things, they were very smart vehicles. The IU, the instrument unit, is right here, just on top of the Saturn 4B. And it's interesting thing in here. If you looked at it, this is where it is on the Saturn V. You can see that it's the same computer system pioneered and worked by Huntsville and the contractors IBM. The instrument unit, you can't possibly see this, but if there's numbers in here, it had its own environmental control system, its own electrical systems, which is battery driven. It had, nobody trusted a digital computer, although it did have a digital computer. So it had both an analog computer and a digital, okay? It just wanted to idea that. So all the vehicles, all the time you see that going up, the person that's driving all those Saturn V's and all the 1Bs is this unit. It's 3 feet long, okay? And it's about 21 feet across. So you get the idea. And it's marvelous. In fact, we were going to the moon. We were in such a hurry that you would see, this is the thing, you would put it on when you stack the vehicle, whether it's a 1B or a 5. The last thing you put on was the S4B here, and then the instrument unit would go on. The next thing up here is the LEM, lunar module. But you can see it had platforms, and inertial platforms, and in fact, it used gas. Gas is driven for the keep the platform floating. That is, it was an early design, worked like a champ though. And in Huntsville, this was going on. This is at IBM facility, but you can see 4 different IUs coming together at the same time. So we produced a production system. The big vehicles are done at Michoud, Louisiana. Here up in Huntsville are producing IUs, and they would be put in a ship, airplane, fly them down to the Cape when they're ready. And this one is a little bit ahead of this one. There's something wrong with it. This is the wire harness all the way around it. Send everything. It has to be made for really put up all the vibration going on. And this one, so there was stuff. This was getting ready to, when you put the LEM in, you don't want to mess with any of those wires and so on. But there's a guy over here. Today, we do it all automatic checkup, but these are real people sit around working on each of those, or most of it. I got another picture, I didn't have it today, standing inside doing the wiring. But that's what it looked like when it was all done. So it's sitting up here on top of this 4B. Now, there's another piece of this vehicle that you've looked at all the time, and you've seen before, but you might not have put it together. There are multiple tanks down here for either oxygen or RP1 in this 1B. That's in Michoud, and you can see here's the jig where they're putting them together. You see they put the structure together. There's a big oxygen tank in the middle, and then it holds everything else together. You kind of use that same idea right here. But you can see the tanks are lined up, and it's interesting. The white ones are oxygen tank, and the black ones are RP1 or kerosene. And the idea is those are the ones that got the letters on, because these got frosty and you can't see the letters. So they didn't put any with the ones that get oxygen. And then, of course, you've seen all these again. If you look at it, you see a bunch of them laying around. All this is done for the size of the rolling machines at Michoud. They did a big one, like you think about the external tank for the shuttle. These small ones we had when we started out, and you've seen it before here. Mercury, Redstone, that's the same size. Those are all the same diameter tanks. Okay. So if you think back, all the things that we were working fast, but the German engineering were also working very smart. So when they cut something that works, like the damn Redstone, we just keep making lots of them, stagger them all together, throw a couple engines on the back end, and off we go with a whole new vehicle. So that was a kind of thing that it was fascinating that we got going. Now, another one, think of something that you've been doing. When we get to orbit, what's going to happen is, of course, the guys are unplugged from the vehicle, turn around and grab the LEM. In a simulator that you didn't even know about probably down in Houston, in Building 5, we had a thing where the vehicle was, and this actually is empty, there's nobody in it, but it could go left or right or up or down. And then this is the LEM, this is double image, triple image even, but what could happen? You'd get into it and the guys would lay over on a cushion so they could be the position, they'd be standing up in this LEM thing, but then it would lay over so that you could dock the top of the LEM to the probe of the thing. Now, how about the probe? How many have you seen one or messed with it and so on? We always talk about this probe and drogue, okay? And in fact, this is one of the things that happened. The drogue was on top of the lunar module, and then the probe was on top of the nose of the command module. And this is 30 inches across, okay? And when it got higher, when you get into orbit, gotta go for it. This is the size of the probe, and you see it's absolutely inert. It's could be put in, it kind of weighed about 50 pounds, but in zero gravity, it was pretty easy to move around. So this is in the lunar module. The guys, when they got it done to get ready to separate, they put the two guys in the LEM, which is down at the end here, and they closed their hatch. And then the command module CMP, or command module pilot, would take one of this thing and install it in the hatchway. This is the same tunnel that you have to go through to get into LEM. So now you're blocking it up. This is just on three sides. You have a thing when these things, like you do so many kinds of cans and different equipment, you put it in and twist it, and it's there. You can see that it gets a form fitted inside each of these things. So this thing is rigged in there pretty good. Now the probe now is a little bit different. On the front of the probe, I'm going to go past right here. This is the thing, we always joke about the male and the female side of that, but this is, in this case, it's the male, and on the probe, it's actually got three little latches, okay? Going back to this other picture, you can see the size of them. And what would do is if you flew it right, you would run the probe into the drogue, you'd get it down to the point that the command module pilot would drive it into this hole, and then those three little latches would latch. So that was what was considered a soft dock. And you would have some flags that would change to barber pole that said that you got a good thing. Then this inside the mechanism of this thing was a gas container, CO2 gas container, pretty much like you use for if you have when you have your bartender gets a spritz of juice or your gas into your thing. That's what it is. Although it was about double size. Each docking used one of those little containers. We'd put it in place and puncture it so it was available. So now once you got soft dock here, then this thing would pull this whole thing down in here using the pressure from that CO2 gas. So this is what the whole thing looked like. Okay, so it's got a 3-point harness inside the command module side of the thing. And if you look around here, there's a double ring, O-rings that are waiting to be sealed up. And back in the, I didn't show you, but around the drogue, it's a race. That is, it's a flat spot where it would have pulled in, okay? When you pull this thing in here, the LEM tunnel comes down all around it. And when it gets down tight enough, it'll seal inside around those rubber rings. And there's 12 latches that automatically will just snap into place and hold the LEM there. So that would be considered hard dock. We never had a problem with those things. There's the whole thing is marvelous that they snapped in and do the job every time. Only once in Skylab that we have one that they had to, when they get into the tunnel, they would push it in. Now remember, there's another hatch back here. All this is done in vacuum. So now that when you had launched and you're getting ready to go to the moon, you're on your way to the moon, you've done the translunar injection. Now you'd open the catch and there was a wire in here just laid against the wall. And they would connect that wire to the LEM, the other side, plug it into the LEM, so that now the command module is talking to the LEM, provide electric power for heaters and things like that is needed while the 3 days on the way to the moon. And then all of this stuff, when they get ready to go down on the moon, they open the hatch again, or they close that hatch, and that's it, safe. On the way to the moon, they get in here, and there's a couple of other switches you control. You think of the engineering here, but this whole thing, you could send a command and it would release these little buttons up here. And then the whole thing would fold up and pull out of the limb. It would undo these three legs. And so you just pull it down into the command module and stow it on the floor. So it's totally out of the way. So now you go back in, the crew would go in and undo the drogue on the limb and pull that down out of the way, and then go up and undo the limb hatch. And now you've got an open hatch all the way through. So you think about all of those times that all those flights to the moon, this was an unsung hero. The engineering where they made this happen and so on. And it's even got checklists right here in case you forget something. They're stenciled on the inside of the cabin tunnel. So here's what happened then. You got through all this stuff and unlocked, turned the command module around, went back, went in, did all those things we just talked about, and then you'd pull away. Now, this is some animations done by Titronics when I was with the company there. I want to talk about this for a moment. This shows that the legs are still folded, but to come out of there, in the limb, sometimes if you're ever in Houston, I can take you walk through the Saturn V that's still there, because it gives you show a lot of this sort of thing. But they extended the legs about 2 hours after this pull free from this S4B. The reason is, if there's any problem with one of those legs, they didn't extend, then they were going to work on it for the next 3 years. They had much else to do, and so they were ready to take care of the limb, make sure that it was able to land. If these legs didn't land, obviously, it's a bad day. Okay. Another thing, the unsung hero, we talk about that, and that's the rover. The first 4 flights, 11, 12, 13, 14, there was no rover. On 13 and 14, we had kind of a thing called a rickshaw. It was a mobile service structure where you could load it up with gear, and then the astronauts pulled it across the moon. Now, the problem happened that 13 didn't land, so that never happened. But 14, the crew there, Ed Mitchell and the first man on the service and the first one who flew, Shepard, were pulling it. They found out that it was really, really hard to do. It was mostly because they had to go uphill to get to a crater, and it didn't work out as good as but 13 was much more of a horse. Shepard was a smoker, so he never quit smoking until the day he left the ground. I'm not sure he didn't smoke a few inside the vehicle on the way, but since it's pure oxygen, I have to assume he didn't. But everybody could last probably 3 or 4 days that way. Anyway, so the rover now, how the hell did it get to moon? It was in Bay 6 on the limb, and when you got to the moon, it was folded up. It looked like this. It's 4 tires. Look like this. Boeing did this. You had actually a navigation device and so on, and a hand controller right here. So that was the way it was. If you look at it, this is the floor of the thing, okay? But it's upside down in this picture. I'm going to go right through this. When you started to deploy it out of the limb, this is a jury rig, so they go through this stuff. You can see that they've got the floor. This piece is floored in the other way. So the first thing they do is it's hinged at this level. And so they drop the floor down and then extend the legs out. So in other words, everything that you saw there was upside down. Now it's getting to be right side up as it's being lowered down. You have a bunch of rope things, these flat panel ropes. They work really good. It was easy for the crew to grab them and so on, but they were very strong too. Anyway, get down to this stage until you get here. This is actually a test model and so on. This is that we're going to use it in Florida. and they didn't have the wheels right. The people, they went through a bunch of redesigns, so it doesn't have a good wheel. But this is John and Charlie sitting here messing with this thing up in somewhere in New York State. They did all this stuff. Not Grumman. Could have been there. Just to give you an idea, the sequence, you land, this picture is a little bit wrong because the LEM was not in this sector of the thing, but it's a good one to look at because you can tell where you are based on the thing. It actually was diametrical opposite to the other backside of it. But anyway, here it is. You come in, you land, you get some of these ropes out, and you start messing with it because it's pretty heavy. So you didn't want it to land on you. So they start working together to drag out the things to get it out. The package comes this way. And the package, by the way, the place it's in, it's a triangular shaped thing. It's about 5 feet, 6 feet tall. And the sides are about 4 feet each way going into the thing. And then the outside is flat. Anyway, you go through the stuff, get it down, and the crew deploys they pull some lanyards and that deploys the first set of wheels. They keep coming down longer. You can see the ropes are working through pulleys here so they can handle this weight. And you know, it's not zero gravity here. We're talking about 1/6. So if this beast fell on you, it still hurt. So they were careful not to get around it. Anyway, they get down to this angle, and then you can see they got the second set of wheels out and popped up. And then continue to lower it down, and as they did, they would undo and do other kinds of things to tilt the front panel down so it locks in place. So now you've got not just what we consider the floor, but you got these two other 3 foot long pieces. And by the way, there's seats there and so on, and this is the control panel. It's now standing up. Here it is down where its feet on the ground, the things, and then here we're putting stuff together. You can see that storage thing it's a triangular shaped thing going there. That's why the wheels had to be tilted to fit in there. And then there's other things in this one and in the MESA over on the other side, the modular equipment storage thing. And that way they bring around, there was an antenna for transmitting back to the Earth. There's a directional antenna and all that stuff that put it on to outfit it so that then it looked like this. Okay, so you can see here, you got this antenna was put in separately. It was not an automatic thing. Whenever they stopped, they would get it going and power it up and so on. The camera is here, all that up in the front end, all that electronics. And then in the, see where the control panel is and the seats and everything else. They were working pretty hard. And I think I got one more just to see. There is, you can see that camera and the antenna. And in the later flights, when they got going, this could be driven, they could improve the direction control and so on. And then they totally controlled the camera. And then 16 and 17, you get actually see the launch off the moon. The guys parked it out behind the LEM far enough that they could get a good picture. 16, they almost did it all right. Ed Fendel, we used to call him Captain Video in the control center. But on 17, he was able to follow the whole thing. And it's really interesting because he had to send the commands 3 seconds before liftoff so that the panning, so the camera started panning up because it jumped off the moon once it lit off. That was a good solid 6,000 pound engine that just drove you quick if you were just the ascent stage. And you've got the wheels that they finally got the right ones, and they did. They looked really good. The other problem is on the flights on 16, I think, no, 17, they broke one of these fenders because apparently the wheel ran over a rock, which put enough indentation into the thing that as it came up, it broke the fiberglass. I mean, it's cold up there. It's also hot, but it broke off the fiberglass. And that's why they made the fix of, as they drove around, the dust was coming up on the wheel and then covering them on their spacesuits. Some of them, that's when they got really damn dirty. So they had to stop and they used a checklist and a couple other things and of course some gray tape and fixed it, made an extension to make the fender work good. Okay. And this is flight unit number 1, the one that flew on 15. So you get the idea of all the things they put it together. But it's this rack, this part was in the Mesa and it was brought around and just popped on there. And then you'd load up all the tools. This is the back end. And this is the one that broke. Okay, so this one, you see the pictures of it with a checklist and some stuff in there. Okay, one last thing we're talking about. Apollo 11, 12, 13, 14, when we flew, the lunar module simulator worked really, really good. And this device worked really good because what you were doing is we just kind of looked at generic areas of the moon. We pretty much would land any place we could. And so that generic terrain looked like this. This was the lighting, looked up in it, put it in the right angle, and you get the, you can see these things are going on. So all that stuff. Well, now 15, 16, 17, we were getting really serious. We knew how to land on the moon pretty good. So they were picking spots that were much more difficult to get into. They were challenging a lot of ways. For example, on Apollo 15, this is a picture of the moon taken by the other guys in one of the other earlier flights, because we knew that we were going to go to this area. This is a rill. A rill is like a little valley. Sorry, but it's probably a lava tube, if you know what that is, that has since collapsed since the moon was here. And anyway, this is Mount Hadley here, and we were going down here. Arrow shows where we're going to go. So this is about 500 feet across and about 200 feet deep. And so this is where we're going to land. Then we're going to cross Mount Hadley and down steeply in here and put it down. So the Army Map Service contracted the Army Map Services up in St. Louis, and they built a thing like this that would go in the LNA. And here's, you can see where the size of the grill would be, and the target's going to be over here. This is 20 feet by 12 feet. And they would jig into there, and there's some pictures I have of just the riggers coming in and get that mounted in place. It's not part of our story here today, but you get the idea. And they put it on a truck and throw a canvas over, drove it down. This is in 69, 70. So you can see that we were doing a lot of work outside the vehicle. When you got that thing in place, this is where the camera's up. The two cameras are up on top of this. And this is the view that they would see. Now we're looking from the wrong end. We're going to be coming from the west, going to the east. And so that the sun is behind you and give you that thing. It's the same thing. If you fly on an airplane, if you see the best view of the airplane is to be opposite side of the sun. So the sun is lighting up the terrain, but not reflecting back at you. And this was the same on the moon. You couldn't come in and land safely. You couldn't come in and land here the wrong way. You just want to make sure that you have the sun behind you. And that's not untrue with fighting in an airplane and everything, all the rest of it. Come out of the sun at them. Well, this is the pictures that you would get. Let me go back. You see that where we're going into this area, and the trend of the rill is like that. So if you look in the lunar module cockpit, this is the commander's triangular window with, by the way, I'll talk about these marks, but you can see here the rill coming down and turning. So the lighting got really good. This is at about 5,000 feet. This would be about 3,000 feet. And these marks are all they were not in the screen. This is just in this photo, but this is for the crew. We didn't have the names of craters this thought down. And so you can see in Earth light, last, meaning really last, you're going to land right beyond that thing. So that's the thing's going on. Salute. And so there was a raft of them. Wives' names, kids' names, all kinds of things. But you get the idea. And I think we're going to stop there and let's take some questions before we run out of time.
No worries, we're not running out of time.
Okay. Questions?
Okay, if there's no
Anna, you always
questions,
have
I do have a few questions for you.
Go ahead.
Hold on, I'm trying to find. I actually
Oh, yeah. You can
prepared
stop,
for a
you can stop
change.
the recording or keep going, whatever you know what to do.
Okay. So one question in the area of career and experience is what inspired you to pursue a career in astronaut training?
Well, that's a good question. Actually, it's interesting. I grew up in Montana, Butte, Montana, and I wanted to go somewhere other than Montana. I had scholarships there, but I wound up going to St. Mary's College in California. It's a men's Catholic organization. I grew up Catholic, so I just wanted to do that. On top of that, once since I was there, when I was a junior, the school turned 100 years old. It was, they had a big celebration for the centenary and all this stuff. And somebody had some real pull at that school because they got Vice President Lyndon Johnson come to the school to give a talk. It was beautiful. It's an outdoor place and everything. He gave a hell of a talk. It was just 1963. And he was talking about going to the moon. Remember, he's vice president. It's in April. And I was there. I was getting a degree in physics to become an optical astronomer. I was going to work on Mount Palomar or Mount Wilson, one of those places, and do all kinds of quasars and things like that. Anyway, that the Apollo thing just flipped my. I knew we were doing Mercury, and now we were at that point. We were about to do Gemini, and it sounded fun, but was not romantic enough. But that day, it was just like the astronomy stuff just fell on the floor, and NASA achieved a whole new thing. Actually, I still do astronomical things. I still have telescope and stuff like that, but it took a different position in my life. So when I was senior, it was interesting. I applied to go to work for NASA, and they said no. I had to have a master's degree. And the error in my ways is that I had applied to Ames Research Center because I liked the San Francisco area, and Ames is a research center. And so that means they want master's degrees. If I had applied to JSC, then I'd been in, but I didn't. So I went off to the University of Idaho to get a solid state physics degree, which is terribly boring for me at the time. I just wanted to go to work. And after Christmas in January of that year, there's a NASA recruiting group, and Joe Tiberville, one of the people in the training business, was there hiring people to go to work in training. In fact, go to work in anything. But by the time I got there, about 4:30 in the afternoon, they said, "Well, you should have been here sooner because we've commitments on all of our jobs except one in training." And of course, I said, "I'll take it. What is it?" So that was it. If I had gone to Ames, or if I had gone to just on JSC, even to the wrong place, it would have been terribly bad. I might
It would
find
be
a way at the
different.
training business, but I really, it fitted me like a glove. And the interesting thing was that just 3 weeks before I was ready to drive down to Florida to Houston, start working, a guy called me down there, and he says, "I'm sorry, we're talking about this. And I thought, oh crap, they read the resume, there's a job done. He said, no. He said, but we want you to come and work at Florida instead. I don't know anything about Houston. I knew a lot about Florida because I knew that there were launched rockets there. And I said, no, don't throw me in the briar patch. I mean, I'm ready to go. And did. And it was interesting. So the first 5 years I worked for JSC, but in Florida. And it was nice because we had a lot of latitude. KSC would do anything for the astronauts. I had a brand new training building that was there. And that's where that simulator went in. In fact, this picture of the simulator, the truck from Binghamton, New York, where they built it, that arrived the first day, the day I got to NASA. So everything fit together. I was sticking my head in every box and asking the people from Link how it worked and why does it work that way and so on. Every electrical, environmental, mechanical engineer, they knew so much more than I did. The difference is with the physics degree, I knew a little bit about all of it. And so it was just the right amount of things to get going.
Awesome.
That was what happened.
Okay, thank you. And what was the challenging aspect of training astronauts for space mission?
It was interesting when I got there. Mercury was already done, of course. And I was there in Gemini, and I watched the astronauts walk in the door in the morning, if they made there in the morning, and the instructor said, "What do you want to do, Gus, today?" And Gus would look at it and says, "Well, let me do 2 or 3 launches. I want to do a couple entries. I got to be out of here by 11:30 to go to lunch." And I thought, this is the way you run a railroad. This is wrong. But I couldn't do anything about that. It just the astronauts would take suggestions and so on. And later we started to be much more resolved when we landed on the moon. The new guys, they wanted to know what the instructors knew. Everybody was learning at the same time. That's why they were asking. Let's say Gus was coming in, and he had been on all Korea and all this stuff background, test pilot. So we just built a simulator, and they used it the way they wanted to. By the time we got the shuttle, though, and I got a management position, we had a catalog. We put together a whole thing about what you do first and what to do second, and so on. And then it was kind of like we went through the thing where you do normal operations, and then you do malfunction operations, and then you would do contingency operations. Contingency meaning the fire, rapid delta pressure, something like that. You take care of it, just trying to keep alive, stay alive. So that turns out then all through shuttle and everything, we had a catalog, training catalog, just like a school.
That's kind of touched on my next question, is that how astronaut training evolved over the years. And you beautifully essentially answered that question, is that initially it was driven by the astronauts, but then became more structured and more process driven of what time or what area of the training they are and how close to the flight.
I've had people
And,
come back to me, just may I add one to that? When the shuttle died, a lot of that stuff died, okay? And except for the Orion, that kind of training is not going on. So if you go and ride any of these vehicles, and let's say just the Boeing has actually got the same kind of training going on. It's better. It also has hand controllers. You can imagine if somebody puts you into a Dragon, it's just got displays. And if there's any kind of vibrations or anything, you can't hit an icon to touch things. I mean, you're totally out of control as far as I'm concerned. The vehicle is the only one that you got. If it malfunctions, especially if you're tumbling or something, kiss your butt goodbye.
Well, there's different approaches in building vehicles and building the displays and controls. And,
that's right. The Starliner, for all its bad things, has all those controls and switches, and stuff like that. So you can hold on to something and do what it is. By the way, the crew is cleared to come back right now. It could be come back tomorrow if some, like a rock hit the station and they were doing deep pressure. But the thing is, everybody realized that all of the problems they had was in their service module, and it doesn't come home. They're going to deorbit and then they punch it away, and so it's going to burn up. So that's why they're spending so much time working on things.
I'm sure Sonny and Butch are not complaining to spend the extra time.
Extra
on
time,
orbit.
exactly.
And
they're at the
the
point of,
researchers can leverage that time for the certain experiments that they have not even had an idea or plans to run. So
You got it.
I think everyone is getting their fair share of excitement from the extra time on orbit. What qualities do you look or were looked at for in the potential astronauts during your time as in the astronaut training?
Yeah, I was asked to be part of the selection committees, but I always said no. I want to kind of keep my options open, when we hire them. But the big thing that would go through was, I think it was really important as the training, you don't want anybody who runs with scissors, through the kindergarten time period and all that stuff. And we had a few that got leaked in there. We don't want somebody that breaks the hardware, and we've had some of those, but mostly it's teamwork. Obviously, they're smart at first, but they're all smart one way or another. But I think that, like Bill Thornton, I just love Bill Thornton, and he was a great researcher, but he also broke things. He was just a big, strong guy, and where he thought was just an agile move, it meant my hand controller was going to have to go to the shop and get fixed. It was like that. I think that the being a team player, but also being a team leader, even though they're not going to be a team leader at first, hire the ones that are going to work that out. And those are the ones we want to keep.
Frank, we have a question from one of the attendees, Carolyn, can you tell a story of green card failures inserted into a training sessions in Building 5? For those that are not in Houston or not related to Johnson Space Center, Building 5 is where the astronaut training took place for the internal for a majority what Frank was showing. At that time, Building 9 was not built yet, and so there was no station. Go ahead.
That's true. Are you talking about this regular sailors, or are you talking about officers that?
I don't know. So the history of green card failures. Do you know anything? I don't think I ever heard about green card.
No, to be honest, I'll tell you a story that's separate from that. I'll come back to it.
Sure.
Green card is a kind of an interesting thing. It means you're immigrant and well, hell, you've been through that. You had one.
Ha ha ha. That's a different, yes, that's a different card.
Well, that's the deal. We had a policeman, Johnson Space Center Patrol, and Franklin Chang Diaz was in on one weekend. And he was in skivvies, he had just shorts and whatever. He had worked in Building 4, and it was coming out and jumped in the car. And just then, as he driving around, and it wasn't a very good car, his daughters all got the good cars, and he didn't, just drive what's left. But anyway, and the patrolman stopped him. You see him get in this car and come around, and he said to this astronaut, but he didn't know who he is. He said, who are you? And the guy gives him everything. He started bracing him. He said, let me see your green card, to this citizen astronaut, And Franklin tells the story. He says, I didn't know what the hell green card even meant anyway. And he's fishing in his wallet, and he pulls out his American Express card, the green one. Finally got to the point this guy realized he stepped on it, that he had stopped an astronaut, not just anybody, but an astronaut. And I think he got reassigned after that. But that was the only green card then. Now let's talk about people, about if you put in the shuttle, for example, in those days, we did a lot of things with friends of ours who would come in and fighter pilots, and all this stuff, because they're about fine. You put in the shuttle and they didn't know how to fly because this rate command we wanted to do, they would over control the vehicles, all that stuff like that. Where the people come in, if they're like airliner pilots, they have a different touch and so on, because they don't throw the people around in the back. They move it slowly and so, and every one of them could do a really good job on the shuttle. So that's that kind of thing. In fact, did you ever ride the shuttle over to Moscow? Did you go back and forth that way?
You're talking about Abbey Air?
Yeah. Yep.
Yes.
Miami M. Yes.
Yes.
Those people come in. It's interesting. They'd come in the night before, and we would take them. And my young engineers, I'd give them the cabin crew. They could have all the stewardess, and we'd take the pilots and put them up, in front. And it was interesting that to a person, they could sit down and they could do the job because they were transport pilots. It's, in other words, where the jet jocks, they're whipping through the sky, and these other guys, they just kind of goose the thing a little bit, and so on. That was a lot of fun. By the way, talking about now the eclipse, but also talking about the aurora. Did you ever see the aurora?
Yes. Yes. Yes.
Because that was a big thing. I still have people thanking me that whenever we take off, after we left Labrador or whatever, we'd take a moment after we ate and we'd shut down all the lights, and everybody, if you could, get on the left side of the airplane and see the aurora out there.
Well, I was privileged, and at the time I didn't know that was a privilege of when we were flying that Abbey Air, the flights to Moscow. The pilots actually called us into cockpit when the aurora borealis was active, and to experience that. And I remember we even put our kids into the one of the pilot seats on the airplane, and so that was their first time ever to experience. I don't know how much, probably don't remember, but that was really fascinating experience.
Oh, it really was. And the aurora from the front cockpit on the 727, lots of windows.
Yes, really absolutely. Yeah,
yep.
It was a 270 degrees view. I wanted to read something from David for you. That Frank, I was an Apollo kid and had my 11th birthday on the day that Apollo 11 landed on the moon. As elementary school student, my friends and I built and launched model rockets, learned rudimentary trigonometry and chemistry, and read voraciously about science and all things rocket related. You and your coworkers inspired me to study math and science, and eventually get a degree in physics and develop a lifelong passion for science and astronomy. Thank you. So this is such a nice tribute. So thank you, Frank, and thank you all of your coworkers, which are
all the people. Let me tell you,
yes.
we were living the dream myself. I at 13, I was launching rockets after Sputnik. Same deal, I learned a lot of chemistry, bad chemistry mostly at first, how to make smoke bombs separate from rockets. It's lovely. Who is that from?
I do not know last name. It's all I can say it's David. It's called Toll David. So whether it's a last name Toll or it's just the nickname.
It's beautiful.
But
that's great.
It's
thank
David.
you for that.
Yes.
Thing.
So thank
you.
If we
had that impact, that's good. That's what we want to do.
Right. Okay. Next question is, how do you see the future of astronaut training with the rise of commercial space travel?
That's a really big thing. I think a couple things are going to happen. First of all, obviously you have to train them. Nobody is born knowing how to do this. And since we keep jacking with new vehicles and new ways to control, they'll all be trained. Whether they be trained the organized way that I wanted to be trained, where the instructors have actually qualified as teaching adults just for any subject and so on. You went through some of that yourself. But I think that it's important that we have to standardize these things, okay? And it should be, we standardize the controls too. That is that if you rent a car tomorrow in London, you can drive that car. It's just like you could drive the one here at home. There's standardization of those things. And I think we should do that on spacecraft controls and so on. It's all environmental controls, and they'll do the same thing. Fix it so the controls are the same, that they're named the same things, so on like that. Okay. When I was at the head of the training program at NASA, I kind of thought of myself as a provost. It's like a third person in a university. That is, you don't run the university, but you certainly run what's going on in the classrooms. And that should be happening still, but it's not quite as well organized because of all these different individual groups. Like if you're going to get in the one out in West Texas and go with the new, what is it called, New Glenn or whatever, it's a different. You're just laying back and take me, John. Let's go home. Now we have the Space Force. I'm sure that not very long, they're going to want a space academy. And I see that's going to come together where we're going to standardize a lot of this stuff. It's going to be forcing function. That happens. And that way, like Ryan, if we hired somebody on the shuttle, it took a year to get them up to speed, just had basic training. Remember, we developed basic training even when we put it together for everybody. So you can speak the same language and even an electrical engineer, but it was some over mechanics and vice versa, because I think that once you have an academy for going to space, then that set of people will standardize, the graduates will make everything standardized.
Thank you, Frank. Following up question to that is, what advancements in technology do you think will have the biggest impact on space missions?
Technology is a tough thing to forecast. That's the whole point, is that somebody had a good idea somewhere and do it together. But I think that, like Franklin is working on his electric engines, okay, so that you could get to Mars in 3 weeks instead of 9 months, that kind of stuff. Anything that has better ISP so that you can move forward faster. Franklin's idea is that you thrust outward for a week and a half, and then you turn around and you slow down all the way. The nice thing about that, even if it's only got 1 foot per second of acceleration, you can have a cup of coffee, or that is, things would lay on the plate when you're trying to eat. I think that the technology of staying out in space is a big one. I think that we have to, medicine, we're still working on medicine. Like if you get a prescription today, right on there it says no good after 1 year, right? Now, that's probably not true. Part of that might be to sell more drugs. But the fact is that it's no good for 3 years, that when you're going to Mars, so if you have a headache 3 years out from launch, you don't have any Advil, stuff like that. So those kinds of technology, that stuff. Food technology is a big one. Just keep palatable. I mean, I could do a whole lecture. In fact, we should do that sometime. Get Vicki Coloras, who just retired, who was the food czar. Rita Rapp she got mentioned yesterday in that thing that was going on. And but the fact is it was crap when the guy started out. First of all, people didn't know if you could swallow. Their whole alimentary canal didn't work. And in fact, It did work really well, as we know. But the problem is the input and the output is still really, really bad. In fact, now on these vehicles, we'll be back to putting a bag in a can, and dealing with the bags afterward. All this stuff. We're back to almost Apollo, where in shuttle you had the great, nice vehicle to sit on, and all kinds of stuff. So that we could talk about that, about the career of those kinds of things. In fact, I always say a country, it's got to be really in space for good, is the one that takes care of those kinds of needs. The food on one end, the waste on the other end, how you deal. And then we should talk in the third, that pole of that one is recycling.
Yeah, and I think another aspect you didn't mention, and I believe it's huge, and the addressing it will impact space missions and space travel and surviving in space, is the mitigation of radiation effects. If we can find somehow some way that reverse impact of radiation, that will be definitely a huge deal for all of us to survive in space.
No question. I think that we have to build tougher vehicles, but also when we have continued to lose lots of astronauts from cancer, even at this altitude. When we go outside the Van Allen, it's going to be a bad deal.
It is. There's a couple thank you for, or couple comments for you, Frank. Keith mentioned that he is thanking you for teaching him how to train astronauts. And Danielle just also put the comment that he tried U2 food tube, pilot food the other day at work, and it was rather interesting. So that was his comment related to when you were talking about the Vicky Flores and food lab and so on.
Sure.
Had a chance to try the astronaut food from the shuttle days, and I would say it was interesting too. Yes. The only thing that I really liked was a drink. Everything else was quite, I'm okay to eat in any restaurant on the ground, on Earth.
You would never
Okay.
go back for any restaurant if they served you the food we serve.
Okay, one last question from me is, do you have any advice for young people aspiring to work in the space industry?
Well, I sure do. And the thing is that study hard. I mean, the fact is that to get here, you really have to excel in your grades. But the thing is, it's not just science and math. You need to have English and something like that, because you have to be able to compete with other people who are very verbal and able to get going. You have to take, as soon as you can, take a speech class. That is where you learn to stand up and talk. Because even if you're smart and you have a best idea, you're going to have to present it to your superiors and convince them that it's the right thing. So excel, but it's excel right across the board. Every subject has contributed something to your success.
I'm glad you mentioned very often those skills are called soft skills. So communication is one of those, and presentation either of your ideas or presentation of the results of your research or results of your investigation. So great point. Thank you, Frank.
You bet.
Okay. Any other questions to Frank before we finish? I know Mike Hilton had a question, but we may touch that one on another time, maybe next week.
What it is? What's the question?
I had a question on the on Joe Engel. I have a picture of him wearing glasses inside the shuttle, and I was wondering if the physical requirement for eyesight was 2020 for astronauts in the shuttle.
It's 2020 when you get in the door. Age takes over after that.
Okay.
So that,
because I have a photo showing him wearing glasses, so I was wondering about that.
especially
was
radio.
Probably not when he was selected, right?
Not when he's selected for sure. No, the
Okay.
fact is that all of them would use reading glasses. They still generally have really good vision, far vision, and so on, right to the last day they fly. But the 2020 is the same as ever, and the good hearing. But time goes on. If you stay in it's just like there's a lot of colonels in the Air Force that wear glasses, especially when they're trying to read the damn checklist.
Okay, there's a few questions, few thank yous, and Frank, I will send it to you also via email. But one question that came as will the recording be available? Yes, the recording will be available. We will put it on SpaceGeek channel, and you're welcome to look on YouTube. I will probably post it later on today. And we have other recordings. And in fact, there's another recording of Frank being at our meeting here a few years back. So if you want to review that one, you're welcome to while you're waiting for this recording to be posted. I see
And then,
Dave.
let me say one thing.
Yeah,
It
go
is,
ahead.
today is a moon day.
Right?
We did land on the moon.
We did.
We did. And we did it well. It's interesting thing. Everybody, if you ever run into anybody who's saying BS, bullshit, I'm leaving it. And I had a couple people, one person that said, I just don't believe there's anybody smart enough to do that, to get ready to land on the moon. And I said, well, there you are. We know that you're not smart enough.
Good response. Good response. Well,
But on top of that, it's just the fact is that the people who did it was so much. And of course, we were at this Cold War with Russians. If we were faking it, the Russians would have done whatever they could to prove that we did it. And what we got from the American embassy in Moscow is a congratulatory
note.
telegram.
Yeah.
At the time, the
Awesome.
day after we landed. Yeah.
Cool.
So they threw in the towel. I mean, they said, we all tried, those 4 N1s that they put together, another one more. So they couldn't get the rest of it into space to make sure. It's a shame.
Yeah.
I talk a lot about Russian too. So when you read the book, Svetlana, you can feed back some stuff there.
I will. I am looking forward to reading a book in a few weeks. And so I wanted to thank you, Frank, for joining us today and sharing more of the personal stories and also pictures from those days. And I'm looking forward to your next appearance on our event. And thank you. And we'll see everyone. You're welcome to join us next Saturday. Every Saturday we meet at the same time, 8:30 here on the Zoom. And as Frank said, we've been meeting on Zoom probably for the last 5 years now and keep on going strong. So if you have a recommendation for another speaker, please send it to my way or just show up and talk. Thank you. Have a great day, everyone.
Thank you, guys.
Bye-bye.